This week we're going to continue our study of the science of sound, and we are going to introduce a low frequency oscillator to our synthesizer. The waveforms that we have now that are creating sound are just simply things that move energy, that pulse energy through a wire. An oscillator pulses energy through a wire. It then hits a piezo crystal that moves a speaker, which then pulses actual air, and the vibration of the oscillator is then transferred to our ear. So the same device that generates the original sound, same oscillator that generates the original sound, can also be used as a control voltage. If we take that pulsing oscillator and slow it down and use it as a control voltage, say for pitch, then the oscillator, which is an LFO, a low frequency oscillator, will make the pitch wobble in the shape of the waveform, or in the shape of the waveform of the control voltage. This is where we get wobble. LFO creates a wobble. We can apply LFOs not only to pitch, but we can also apply it to cutoff or any of the various parameters that our synth has. So we can make it part of the wobble sound is not only the pitch being oscillated, but also frequently the cutoff sound is oscillated. A number of things can be oscillated with the low frequency oscillator, and experimenting with them are going to give us some interesting wobbles. So that's one of the things we're looking at this week. In terms of the history, we're looking at Hermann von Helmholtz this week, who was born in 1821 and did a vast amount of scientific experimentation in acoustics, physical acoustics, electrodynamics, fluid dynamics. He was just an incredibly accomplished scientist who wrote a book in 1861 called The Sensations of Tone. He's interested in the physiological effects of tone and resonance and vibration. He also invented a device called the Helmholtz resonator, in which we could study resonant frequencies. If there's a frequency in the air, this resonator was shaped a certain way and would resonate at a resonant frequency and would amplify the sound of this resonance that would be the particular resonance in the air and dampen all the other sound. So the Helmholtz resonator was a very interesting way to study basic sinusoidal vibration. And the analysis is related to our Fourier analysis that we were talking about last week, and being able to separate sounds into individual sine waves, which are the simplest forms of sound, the building blocks of sound. Another thing a very important thing in synthesis that we thank Hermann Helmholtz for is the ADSR envelope. He studied sound and determined that it had these different phases, and he came up with an ADR scenario. Today we speak of attack, decay, sustain, and release. He just described attack, decay, and release. But these knobs on a synthesizer are really because of Helmholtz defining sound this way. So that's basically what we're going to be looking at this week. It's very exciting, and I'm really looking forward in this week into getting into low frequency oscillators.